In today's lesson, we're going to do some more formal triangle proofs, but we're going to be incorporating the idea of the definition of a midpoint and the definition of an angle bisector. Let's get started. Before we do some proofs, let's go over what it means to be a midpoint. So for our definition of a midpoint, we have a point in the very middle of a side, and it creates two congruent portions for us. So we have a portion on the left and the right that are going to be equal or congruent. If you look at our second diagram over here, let's say that we're looking at our side on the left, and we have a midpoint, so we put a point in the very middle, which means that again we have two congruent portions. So if we have a midpoint, it creates two congruent sides for us. Let's go ahead and use that in our proof. Alright, let's go ahead and look at our proof here. We're going to begin the same way we always do. We're going to write down our given information. So we know that B is a midpoint. I'm going to abbreviate midpoint with MP of AM. We also know that AR is congruent to RM. And our first reason is always given. Okay, I'm going to go ahead and mark that on our diagram. So we know that AR is congruent to RM. We do know we have a midpoint, but we can't do anything with it yet. Alright, knowing we have a midpoint, it tells us things about that side. So we know that the entire thing AM has been cut into two equal portions, which would be AB and BM. So we can go ahead and mark those as being congruent. So AB and BM are going to be congruent. And that's going to be our next statement. So we would say that AB is congruent to BM. And again, our reason why? Definition of a midpoint. So because we were told that we have a midpoint, we know that we have in fact two congruent sides. Alright, one last thing we got to do before we can say our triangles are congruent. We can see that our two triangles share this side here. And we can go ahead and say that those sides have to be congruent then, which means that RB is congruent to RB, and that is because of our reflexive property. Alright, now if we go ahead and look at our pattern, let me mark those sides first. Okay, so now if we go ahead and look at our pattern, we see that we have a side, a second side, and a third side. And another triangle also has side, 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 which means that our two triangles are going to be congruent by the side, side, side theorem. And our triangles are again triangle ABR, and that's congruent to triangle MRB. Alright, with our next proof, again we're going to go ahead and write down the given information. I don't have a whole lot of space, so I'm going to cheat and just draw a line and say that our first reason is again given. Okay, I can go ahead and label this information. Specifically, we know that RMA and BCA, those two angles are congruent. So those are going to be this angle here and that angle there. Alright, for our next statement, we do know we have a midpoint. Again, we have A being a midpoint of MC. So here's MC. Because A is the midpoint, it cuts it into two congruent portions. I'm going to go ahead and mark those portions. So we have AM and AC. Those are congruent segments, and that's going to be my statement. AM is congruent to AC, and again, our reason for that, definition of midpoint. And I'm going to abbreviate midpoint with MP. Okay, I didn't leave myself a whole lot of space here, but for our next statement, we do have our triangles connected, and they are connected at the very middle with an angle. So I have congruent angles. I'm going to go ahead and name those angles. We have angle MAR, and it's going to be congruent to angle CAB, and that is because they are vertical angles. And vertical angles are congruent. Alright, now that we've marked our triangles, it is kind of hard to see, but we have an angle followed by a side and another angle for both of our triangles, which means our reason the triangles are congruent is the angle side angle, and the name of our two triangles, we have triangle RMA, which is congruent to triangle BCA. Alright, let's talk about the definition of an angle bisector now. Similarly to a midpoint, an angle bisector creates two congruent things. In this case, they are two congruent angles. So if you look at angle P here, we can see it's been cut in half and we have two smaller angles that have been marked as congruent. Look at your second diagram over here, we have angle A, and angle A has been cut in again to two congruent angles using an angle bisector. So just like a midpoint gets two congruent segments, an angle bisector creates two congruent angles. Now let's go ahead and try a proof using angle bisector. Again, we're going to start with our given information. Again, I gave myself enough space. You should write this down, but I am cheating a little bit. The reason though is it is given. Okay, I can mark some information here. I know that AX is congruent to AY, so I'm going to go ahead and mark that. Alright, now I have my angle bisector. I know that angle XAY is cut in two, and XAY is going to be this top angle up here. And because it's bisected, it creates two congruent angles, one on each side. So we have angle on the left and angle on the right. So for our next statement, we need to name them. Angle XAM is congruent to angle YAM. And the reason for this is going to be definition of angle bisector. And we can abbreviate angle bisector with AB. Alright, one last statement before we can say our triangles are in fact congruent. They do touch and they actually share the side down the very middle. And with our previous proofs, we can say those are going to be congruent. And we'll name our sides. So AM is congruent to AM, and our reason is the reflexive property. Alright, now for our final statement, looking at our triangles, we have a side angle side for both of our triangles. So we can say there are two triangles. In this case, triangle AXM is congruent to triangle AYM, and that is because of the side angle side theorem. Alright, here for our last example, again we'll be using angle bisector. So we start by writing down the given information as our first statements, and we know that our first reason is always going to be given. We want to look and see if there's anything we can mark down, and we do have some bisectors, but nothing has been named as being congruent, so I can't mark anything yet. But I can go into my next two statements, and I'm going to try and combine things a little bit here. I have two angle bisectors. So I know that angle RAB is bisected, and also angle RMB is bisected. Because those two things are bisected, I have two sets of congruent angles. So I have one at the very top, and I have one at the very bottom. Now since I'm using the same reason, which is angle bisector, I can name those angles congruent in the same step. Alright, so give me a second here, let's see. Angle RAM is congruent to angle BAM. And again, for the same reason, angle RMA is congruent to angle BMA. And the reason for both of those is definition of angle bisector. Again, I'm going to abbreviate angle bisector with AB. We could split it up into two steps if you wanted to, but since we're using the same reason, we can also combine it in one step. Alright, for our next statement, hopefully we notice that our two triangles share, again, this middle side. So we can mark that as being congruent. And the reason we can mark that as congruent is because of our reflexive property. So we'd say that AM is congruent to AM, and again, that is the reflexive property. Okay, looking at our triangles now, hopefully you guys see that we do have this congruent, and they're congruent using the angle side angle theorem. So our two triangles, which are triangles RAB, is congruent to triangle RMB, and again, that is because of the angle side angle theorem. Alright, that's it for notes. Go ahead and work on your homework.